in Python. I am using the technology of Google. Uh, I was doing my Python notebook in Collapse. It's a technology that you can use in your browser without installing anything in your local computer.
Yes, you can share the screen.
Yes. One second. I will share my presentation. So can everybody look at the screen of my presentation?
Yes, it is visible.
So for today, we are going to talk about production analysis and nodal analysis with Python and machine learning. Let me 1 second. I will make the slide presentation. Comments. As I said, I study in National Autonomous University of Mexico. I did my bachelor's in petroleum engineering in 2011. Also, I completed a master's degree in reservoir engineering. My thesis was pressure transient analysis in my master's degree and hydraulic fracturing in my thesis for bachelor's. National Autonomous University of Mexico is a great university. The world ranking is 136. Let's start analyzing what is Python. Python is a programming language that needs an interpreter. This language is not compiled like, for example, C. You need a program that interprets the scripts that the one writes on the on the development environment. It's a high level language. It means that the language that we're typing is almost human language. Everything is written in English. The commands are written in English, and almost everything is already programmed through the libraries. And also, uh, this language has dynamic semantics. This means that it has a lot of libraries. Data science and machine learning is a very big field that extracts knowledge and insights from data using methods from statistics, computer science, and domain expertise. In this case, the domain expertise is petroleum engineering, petroleum industry. We are going to apply programming, statistics, math, and 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 probability for the oil industry. We are going to analyze data that belongs to the oil industry. Uh, the technology that we are going to use today is Google Colabs. I am typing the link for Google Colab. In difference with Anaconda, in Collabs Google, you don't need to install anything in your machine. You just open the link and you can start creating scripts in Python. For that reason, it's very practical to use this technology. Some other technologies is Anaconda. In this case, you have to download the software from this web page into your computer. It's a kind of set of servers that run Python and the environment that requires Jupyter notebooks. And then you open the environment through your browser also, but you are running a local server on your machine. But in Anaconda, when I have used this, it requires a lot of memory in your computer, a lot of gigabytes. So I prefer Collapse. It's more practical and it's almost the same. We are going to analyze this Norwegian oil field. It's an offshore oil field that was discovered in the 70s, but started production in 1995. The operator is Equinor Energy. Um, the number of the field is Troll. We're going to download the data that they report in their webpage. I am typing the where is the link to download the data and study further the reservoir, the field, sorry. So uh, let's go to the notebook. The units that this field uses is everything is reported in uh, meters to the cubic meters. So but this is reported in oil equivalent. Oil equivalent means that also the liquid production from oil and also the condensates from the gas when the gas condensates under certain circumstances, and also the gas can be converted to liquid gas because under a certain pressure and temperature conditions the gas can be liquefied, and there is a conversion. Everything is reported in oil equivalents. So the first step that to run our program, we are going to use these libraries OS, Pandas, NumPy, and Matplotlib, PyPlot. So the first step is that we are going to download in my case, I have already the Excel file in the notebook. Uh, you can go to this section of the Jupyter notebook and you can download files to this section to use the files on the script on the environment. So let's analyze how comes this data from the Equinor reporting of the production. It's a uh, Excel sheet. Some of the rows are not part of the table that we are going to use. So this is important information because we need to set some parameters later. The columns start in the row number 6, and the columns from the Excel program that are using the cells are from A to F, but we don't require F. Also the columns, the headings are coming in Norwegian. R is years, oil J is oil, condensate is condensate, and the rest is understandable. Liquefied natural gas, also gas production. And after in the column number with the name F, they make a summation of everything in terms of liquefied natural oil equivalent, sorry. They sum the production of the gas, of the condensates, and the liquid production to a total that is equivalent to the oil equivalent. So this is how the spreadsheet comes. We're going only to use one of the labels, one worksheet only. So let's analyze the Jupyter notebook. For loading data using pandas, we need to type we are setting a variable df is equal to pd. PD is how we are importing the pandas library. Then we are using the method read Excel. This is how can we read files that we need to load into the notebook. So where I am typing here the name of the file. This comes as a string. That's why I am using double quotation. And as we were analyzing, the table of interest starts after 5 rows. So there is one parameter of the arguments of the read Excel method for the pandas library that is its name is skip rows. So we're skipping the first 5 rows, as I said in the beginning. We're going to start loading from the 6th row. This table is what we are going to use, and we are not going to use the summatory of the rest of the production. So we're going to use only the column E. And let me check. So let's go to the notebook in Jupyter. Uh, I am using the browser. Here is the Jupyter notebook, and also the other parameter that is very important is what columns we're going to use. This is another argument for the read Excel method in the pandas library. So this is equal to another string. If you check, we are typing A, and we are using a double point and E. This is like a slide. We are sliding from column with the name A to the column with the name E, and also it comes as a string in double quotation. This is how we're writing the parameters that we are going to use. So we load the table, and we are converting with this method directly as a data frame. Uh, Pandas has a method to work with data that its name is data frames. The data frames is like working with a database with a table that comes from Excel, but we are working with the memory of the computer, and we can make change to the data with some scripts. So to analyze the first 5 rows of the data frame, we can type data frame, the name of the variable that we're assigning, dot head. For example, if I type head number 10, we analyze the first rows. Also, we can use data frame tail to check for the but if I type at the same time the two commands, it's only showing the last command, the tail. So to make it display both, we type display head, and also we type display the tail. And when I type display tail, we are reading the last part of the table. We have 34 rows. Here is the tail. So the comment that we are checking when we load the data frame is that the heading comes in origin. So the first thing that we are going to use is we're going to change the name of the columns. For doing this, we type data frame, the name of the variable, with a dot, and also we assign the method columns. And this is equal to this will be our new headings. We have R oil condensate, natural gas liquefied, and gas. So we're saying gear, oil, condensate, liquefied natural gas, and gas. And now that we are running the heading of the data frame, now we have gear, oil, condensate, liquefied natural gas, and gas. So this is how we can change the name of the columns. Another method is data frame is equal to data frame rename, and we can say the first comes the name of the. We're going to see this later also. This is the old. This is the old old name, a new name, and for the uh, so this is another method. We are going to check how to use this also because it's very important because when we are slicing on the data frame and we assign the slide to a new variable, you cannot make change you cannot make a new change to the new data frame because it's in the memory is a reference to the original data frame. So we need the classic way to change the name of the column. So we have here, let's set this as a comment. To set something as a comment on Python on the Jupyter notebook, you have to set the dash. And then we have this new data from year, condensate, liquefy natural gas. So the next thing that we have is we have to check for the what kind of data we are loading in the data frame. So for doing this, we type data frame, the type, sorry, with plural. Uh, and this makes a table that it's telling you year comes in an integer. This will be a trouble because normally when we're working with Python, we need to set a standard for the type of data when we are talking about dates, years, months, days. Also, you can include hour and milliseconds and everything. So year comes in integer. We need to change the integers. Oil comes in float, condensate in float, and the rest also comes in float. So we are not going to have any problem with the rest of the information, but we need to make a change in the data in the year. This production of as we were analyzing comes in a table that is reported yearly. It's not a daily production or monthly production, but it's the total production in a year for the entire oil field. And the units that are reporting the Equinor people is oil equivalent. So this is how we choose the what column we are going to work with. We type the name of the data frame, which is df. We use double bracket, and we type under double quotation the name of the column that we want to work with, that is year, and we equal this to data frame. Uh, this is equal to the same column that we're going to work with, dot as type, and this comes in a string. We first are going to change this to string. So sometimes some commands in pandas they need to read a string, but in this case the method that we're going to use can use a string but also an integer. But just to have the information as a string, we're going to type to convert everything that comes in the column year. We are going to convert everything to the type of string. So let's check what happens. We have the same data. The data is not corrupted. Then data frame, we are going to type again as type. Oh, sorry. I already was writing this. Let's skip this step. Yes, we can do to check how is working everything. Data frame, the types. And now for the year, we have an object. This object comes in the strings. We have no longer an integer. We have an object, and the object includes strings from each year. So to changing the object to the format that we're going to use, we type pandas. We select the column that we want to change, that is year. This is equal to pandas, convert to data frame. We type to data frame, to datetime, sorry, pandas dot to datetime, and we choose what column we're referring to, that is year. And then After this, we have everything in datetime. This is a standard for Python. Uh, when we are working with dates, with time, we need to convert everything to this format. So after this, you can make computation. If you want to acquire the difference between one date and another, you can change with this way, and you know the delta time that you need. What is the difference between 1993 and 1994 is 1 year. So you can do this just with a simple operation like how much is 10 minus 5. So now everything is converted to data time, to datetime. So this is a classical method, but it requires a loop. I am sending everything that comes in the year column to a numpy array, and I am creating a new list that is time series, but it comes empty. So for I in new array, uh, what I am doing is time series. I am appending everything for every element in the year column as a timestamp, where I am converting in this case one by one the values of each year. But this is a classical way of converting data. So after this, the data frame, we need to slide to look for information inside the data frame. The way to doing this is using .log. The name of the data frame .log. So inside the square brackets, we need to choose the column that we are going to work with, and what is the information that we are looking for. But for log, when we are working with log, we only search in the index or specified. We are only going to work in the index, is looking for information in the index or specifying. In this case, I am specifying the year. So for example, let's check. We don't have the index now is it's a series of numbers. For example, if I look for the index data frame log, then I type 19 1990 01 01. It's not going to find anything because I don't have any index. It's not finding anything. But what happens if I first change data frame uh, data frame set index, let's say year. We're going to set index data frame set index year. So now the index is the year. So if I try to find data frame log, let's try to look for something. 1990. Now it's finding information, but before this is not finding information. Check indexing data frame log. There is it. So now it finds everything differently to before. But if I unset the index, For example, data frame is equal to the reset index. Now we're not going to be able to find information through this way. Now it sends an error. So loc only finds information in the index. So let's continue. So the other method to slicing information in a data frame is using iloc. In the iloc case, we look for the information in this way. We type data frame iloc, then we look for rows and columns. So we are slicing in this case from the row number 0 to the only two first columns that come in the table. Let's change this for 3. So in the first place, we look for the index in the column, the column in the index 0. Index 0 in programming, almost everything, when you have a collection of something, everything starts with 0, and then 1, 2, 3, and so on. But in the first position when you are slicing with using iloc is the index of the column, and after the double points, you use the position of the length. You have the first column that is here. The first, then I want to choose to the second column. So in the case of the second value, when you're slicing, you are not using the index of the column, but you're using the position of the column starting from 1. So we have to check for these details when you are slicing. Also, the rest works with as when you are like slicing an array. When you're slicing a list, if you type double points and -1, you start from the last value to the first one. Let's look what it's doing here. So the first value is in the year 2024. That is the last value that comes in the original data frame. And it comes with the associated oil production, that is the last production, that is uh, smaller than the first reported production. So that's how we can slide a data frame. So let's continue. You can also slide using the classical sliding method when you're slicing a list, but you can also slide a list. In this case, in the second value, after the comma, uh, let's remember that when slicing, first value is rows, and second after comma is columns. In this way, data frame log rows and columns. So in this case, I'm selecting the column 0, 1, 2, and 4. I am jumping the one of the slides liquefied natural gas. Let's check. But let's jump condensate and let's report oil and gas. So I delete number 2. And now I have oil and gas. So sometimes we need to work only with certain information that comes in some columns like oil, gas. In this case, they are reporting also liquefied natural gas, condensate, and the total accumulated of all the production, liquid and gas. So when we're slicing a data frame without using loc or reloc, you can do it just typing the name of the data frame. Like when you are working with a list, in the first value, as when you're working with a list, you type the index of the first column, that is 0. In this case is year. Let's check. But let's for example, 1 0 1 2 3 1 2 3. Let's say we're jumping here. Let's type 2, and it's not reporting the rest. With oil condensate, gear oil condensate, liquefied natural gas, and gas. So the data frame that we're using, because we were skipping some columns, is this. So what we're going to do is change the units. Everything comes in oil equivalent, so we're going to multiply the column oil, the column liquefied natural gas, and also condensate times 6.29, because it comes reported in the it comes reported in the Equinor reports that everything is reported in oil equivalent. So I am changing also the name of the columns. Year oil now comes in million of barrels, condensate also in million of barrels, and liquefied natural gas in million of barrels, and gas also in oil equivalent in barrels, because it's reported in cubic meters. So after doing this change, we have these new values and these new names of the columns. I am also changing again the number of the columns. It's a simple way. I am creating a list with a with a collection of names that are corresponding to the names that we're going to change in the original data frame, and this will be the new names. So data frame 1 is the name of the new data frame, but in this case is a is a is a redirection internally in the memory of the computer, is a redirection of the original data frame. So after doing the change of the units that are reported, the change is made for everything in the values in the columns that I am multiplying. So let's analyze with the command describe. I can analyze some a collection of statistics that will be very useful when we are doing, for example, machine learning. This Jupyter notebook is available in the in my drive. I hope you are receiving the material that we're working in. You can download from Google. So describe the maximum value is 133 million of barrels, and the minimum value is 0.333 million of barrels, reported in 1 year. So it's about 300,000. So we can also slide with a condition. We just type the name of the data frame 1. We open double brackets, and inside the double brackets, I choose the column that I want to work with. Data frame number 1, I also open double brackets, and I select the name of the column, and it has to be matching uppercase and a lowercase. It has to be exactly the same string that is the name of the column that we're going to work with. And I am using the symbol greater than 133. So how many, if you check the the only value that is greater than 133 is nearby the maximum value. So I am choosing the greatest value, and for I want to know when is the date that this oil field reported in 1 year the highest production. It was 2002. So this information will be useful when we are doing machine learning. Also to know what is the peak of the total of the maximum production in the oil field, the history of production. So let's check data frame 1 head. Everything is okay. And we're going to check also the types. Daytime comes in daytime, and the rest comes in float values. So for plotting, I am using matplotlib .pyplot as PLT. This library is very easy to use. You just choose what is your X values. I am typing the name of the data frame, also the name of the column. This will be x. X is all the years that are reported. The y values, like for example, when you are plotting a table that is only x and y, this is what we are doing. We are only choosing what is x and what is y. Data frame number one, with double brackets, I specify the name of the column is the oil production, oil in million barrels. So x is year and y is oil production. So I am also plotting condensate and gas million oil equivalent barrels. Uh, then I am creating you need to create all these objects to finally make the plot. You have to type to specify plt.plot. Plt comes from the name of the library that we're using. Dot plot is a method to specify the what is the label. Yearly production is the label of this plot that we are creating. Is the name of the graph that we are creating. So I can plot in the same graph some values xy, xw, xc. So in this way, we're going to plot oil, condensate, and gas in the same plot. In this way, you just say PLT plot. Are the couple of values for x and y, for x and w and x and c that are corresponding to the oil, condensate, and gas. Also, we're setting what is the y label. The y label is the y label is how we're going to label the y-axis. I am typing million oil equivalent barrels. Is here y, this is y, million equivalent barrels. And also x label, that is year. Here is year, the x label, here is it. And subtitle, that is what is the title of the plot? I am typing oil and gas troll production. Let's type class. Now the title includes class. So if you check the profile, the report is reporting from 1992 to 2024, and the highest production is, as we are checking from statistics, about 133 million barrels per year in the 2002 year. This is the blue line, the oil production. The green line is the gas production that by 2024 is increasing, and there is some condensate in this part of the production. It's the yellow, sorry, the orange color. So with this information, what we are going to do? I will analyze quickly. I found there are many libraries for doing machine learning. Machine learning is doing regressions. The simplest way of regression is the linear regression. When you do a linear regression, you are just typing linear regression. Is you're just using the line equation, that is y is equal to slope plus b plus a constant. So this is the simplest regression that we can do when we are doing regression, linear regression. But in this case, when we are talking about oil data, the regressions include stochastic regression. Is that the stochastic regression is when you use the shape the shape of an S. The graph of the stochastic regression has the S shape, and also when you are using when you are doing some polynomial regression, you have you have curvatures uh, depending of the grade of the grade of the question. So in this case, I am using the Prophet library that was recently launched by the programmers that make Facebook. So this is the how you can import the library Prophet, import pandas as PD. Uh, I'm going. This is experimental for oil industry because they launch this. But you can analyze how you can do regressions with Prophet in the Python node in the Python notebook that you can download on the drive from Google. But Google was publishing a very simple way to doing regressions. you just use these lines of commands. What I am doing here is I am doing I am selecting the only the declining production starting from the highest production reported from the statistics is the year 2002, and for the column year I am slicing from 2002 to the greater values to the last production reported, that is 2024. Yeah, and the name of this data frame is data frame profit. So if I run this new data frame comes from 2024, sorry, 2002, 2003 up to 2004. Let's type display oil data frame, also display data frame oil. Yeah. And in this case, I will report the tail. Ah, some type. Uh, data from oil. Ah, yes, I am missing a couple of parentheses. Ah, here is it. So this data frame comes from 2002 up to 2024. I am missing the reports from 1992 because I don't need the increase in production. I only need the decline of production because we're going to do a linear regression. So everything is written in the data frame. It will be available online. So you can also later analyze the scripts. Again, I am changing this library needs to report the columns in this session. So you can do it. You set data frame oil rename. You set what we're going to rename from our data frame, that is the client production. You type columns is equal to the year. This is the old value. This is the old name of the column. And this will be the new name of the column, DS, oil million barrels to Y in place true. So I am changing only the names of the column, DS and Y. This only includes the years, and which is the DS column, and also the Y column that includes the production for this. This is a general standard for this library. This library needs the columns to come in this format. So let's analyze again, describe. The maximum value is in 2000. For the DS, the maximum value is Y for the column Y, but the year was 2002. So let's check. Let's continue. Now we have another 15 minutes. So uh, for this case, we're doing a stochastic regression. Then we need to add a cap in a cap in a in a stochastic regression is the highest value in the function. So I am typing data frame oil cap is equal to 134 because remember that the highest value we have is 100. Let's check. Yes, that's right. Stochastic. Let's read. Here is it. This is how is the shape of a stochastic regression. It has a S shape. The linear the regressions in machine learning use a lot this function, this equation to for data classification, also for regressions. This is not obviously a linear regression, but it's because the shape, look at the shape, the shape is has the type of an S. So how this shape is made is with this equation. L is the maximum value. The L is the curve's maximum value. So K is the logistic growth rate or steepness of the curve, and x zero is where you have the middle point. In this case, x0 is in this part. X0 is this value 0 in the x-axis. Is the middle point of the stochastic function is 0.5 in this case, the value for the y. So let's get back. So that's why I am choosing 134 as the growth. The growth is this one. The column is in ECAP 134. So for the next, I am going to make predictions from the model that we are creating. We're going to analyze the further 5 years, only 5 years because the data is declining, and the frequency will be every year. It will be reported. It will be reported here. Uh, it can be reported daily, monthly, weekly, but in this case, I am reporting yearly. I am including the history. So this is the result. We have 2000. We are into the last production reported was 2024. Where I have 2025, 2026, 2027. This will be the prediction. I am here. We are creating a data frame that includes future values. So again, the cap is the maximum value is 134 million barrels, and we are going to create these parameters are for the regression. For each step, it has some parameters: y hat lower, upper. This is if you want to analyze step by step the calculations with your pencil and a white paper. So the forecast has to be written in this way. You create the model, dot predict, then you use the future that we just created. Future is the data frame. We are creating a future data frame with 5 years in in the future in advance. So after results, you can analyze the data. Uh, and the plot is this one. This is the stochastic linear function. Uh, I was playing with this library. This is done by Facebook, but by Facebook employees. This is the feed that I have. For this, if you want, you can for homework read the manual of the Prophet. Let's go to the manual. I am typing somewhere here. Logistic growth. Here is it. You can go to the link in the data frame. You can read the instructions. Are very simple to follow. Also, this includes these are some of the feeds. We have another 10 minutes. This is the feed. The Facebook coders are explaining how to do regressions with this library. It's very simple to use. Here are some examples. And for homework, you can check this this library, this link that Facebook is reporting, and you can download the reference manual. Here is the manual, and here you can set the parameters, or it also includes some examples. You can set they are reporting what is every parameter. Let's find examples. Such arguments, description, examples. Here is it. Data frame. They are creating a data frame. The only thing here is that they are reporting the manual in R language programming, but this is almost the same if you know how to create the data frames. Uh, then you can do the future predictions. In this case, they are creating 335, which is 1 year because they're reporting daily. This library works only with time series data. Then you need the data you can use. You cannot use this regression with other type of data, only with data series, which is oil production. Then here is telling how what is every value of the arguments that takes the library. So let's go back to the data frame. So this is my relation. Profit 1 million barrels. logistic growth. Yes, we were checking the link for the manual. Here's the regression. And also I am including also a scikit learn model. I am using we don't have a lot of time. We are also missing the the nodal analysis. But let's make a quick review of what I am presenting to you, and you can check in detail when you download the data frame, when you download the notebook. I am using a polynomial regression. This is how you import the library. This regression is a third degree. Here you can set if it's 1 degree, 2 degrees, or 3 degrees. So for my fix, I am using 3 degrees, and it's almost the same process. You have to set what is your x, what is your x value from the x axis, the y values for the y, and also in the same way, the fit you have to include both columns. Uh, that is, I am extracting the values from these columns in this way, and polymodel is done with this fit, make pipeline, polynomial features, degree 3, linear regression. This is for the x-axis, for the y-axis. So the future years, I am creating a new range that is the minimum value of the years and the maximum value of the years. That includes, this is only the declining of production. And to make a prediction, you include with the model that we created, we include only the values that we're creating, that is 2002 and 2025. I am building a forecast data frame. This is with future values, as we were doing uh, with the Facebook library. And then we just need to plot everything. So this is my fit. This is with third degree. This is from 2000 with the peak of production to 2020. Uh, let's check. Let's check. 2028 or something like this. Yeah, 29. Sorry. So we check that our model goes to negative production that is not physically possible, but is a good fit. But this means that this field soon will be shutting down production. Uh, it's intersecting the zero axis by before 2025. So maybe the engineers in Troll Oilfield are closing out every well. So now let's analyze nodal analysis. I am using the data from one Petrodata. I am including the links. The theory you can study the theory from these links. Everything is in the notebook of Jupyter. Uh, I am typing what are the equations that I'm using Vogel, and this is not Fedkovich. Sorry, it's Vogel standing. So the reservoir pressure is 2,500 psi. The boiler pressure is 1,600. The flowing pressure of the well test is 1,650, and the oil production is 400. First, you need to compute the productivity index. Here is the equation. Also, the absolute open flow when you are let's go to the slides. This is the unit of the oil filter. Yes. When you were analyzing the entire uh, production system from the reservoir to the tubing to the surface, we need to analyze the system in parts. This is called the production system. The first pressure that we need to analyze is the reservoir pressure. Then the turbo pressure from the reservoir original pressure to the borehole is the first drop of pressure, because we are drilling a well, and the maximum production that we can have this is the inflow analysis. This is an imaginary case, uh, because we're analyzing this node, the bottom of the hole, and we're analyzing the case when you have zero pressure in the bottom of the well. Remember that the fluids travel from the point where you have the highest point of pressure to the points or to the volumes where you have the the less the smaller values pressure. Then if you have a bottom hole with a zero pressure, this is the maximum production that you can have in the influx. So we're only analyzing in this case the the inflow in the bottom of the hole. That's why the first step to analyze this is the case when you have zero flowing bottom hole pressure. So let's get back to the notebook. Every question is written here. We don't have more, we have one more minute. You can check. This will be very useful for you because uh, many companies, if you want to have a software to compute nodal analysis, you have to buy very expensive licenses. But it's a good business if you later want to create software. But you can also create your own tools. Just using some tools available online. In this case, is Collab. So I am going to analyze only the results. We don't have time. We have about not 1 minute. So this is the outflow. So this is the same result that you get when you are using commercial software. So with this type of technology, with a Jupyter notebook, you can analyze thousands or hundreds or I don't know how many oil wells can a field have or a company, but just with some scripts, and you can automatize everything and start saving money for the companies. So this is the final result. Here's the plot. So we don't have more time. From me, from me, so this is everything. I hope these tools are very useful for you. So let's open 5 minutes for questions or 10 minutes.
Yes, participants, you can ask the questions if you have any. The session is open for question answer. Yes, we have a question in chat box, Mr. Oscar.
Sure, yes. How to evaluate the performance of a machine learning model for prediction of flow rates? Uh, you do it in function of the, the parameters that are normally used in the machine learning. For today, it's only a demonstration. Today is a webinar. We are not going to cover everything. You can do further research on your own. But for example, it's very simple. You have some test data, and you have some training data, and you have also the forecast. But when you are comparing the real value that you have in your data, and you are comparing the same reported value, the same result for the forecast, you just make a difference. You just make a difference between 2 points. This is the first value that you are analytically, geometrically you are typing. What is the difference between the point that you're getting in a value, in a pair of values that you're calculating, and you also compute all these. If you have the same point, it means that you have a distance of zero. It means that your model is perfect for that point. What happens if the model is perfect for every point? Your model has zero error. But if you have some distances for the further points, you just make an average of the results, and this is how they compute the models. The minimum square error it just comes from the distance of every point to to the actual value, to the real value. You can do it for you can do further investigation on your own. In this time, we are doing a demonstration about some of the applications of these technologies, data science, Python, and Jupyter notebooks in the real data that is reported on the fields. So, any other question?
Yes. Any another question? Anyone else would like to ask something or give some feedback? Yes, we have one. Have some presentation. How do we validate ML models in production analysis to avoid overfitting, especially when we have a limited historical data? You are on mute, uh, Oscar,
Yeah,
Mr.
sorry,
Oscar.
I have some trouble with my computer. Can you listen now? Yes.
Yeah.
Yes, sorry, there's one icon in in my screen of my laptop. The application is has some kind of bug. He was trying to press the audio button, but it is typing some pencil. Yes. Eh, eh, Sorry, I was also with trouble with the audio. Can you say again the question, please?
Yes, just a second. So, how do we validate the ML models in production analysis to avoid overfitting, especially when you have a limited historical data? This is the
Uh,
question.
yes, it's a very good question. Remember that part of data science is that you have to know the what industry you are talking about to understand the magnitude of the values. So the first step that you can do to validate data is for example, eliminating overfitting. We recently had a course when the first step was deleting overfitting. But when you are talking about oil industry, there are many circumstances that can change the data. Because, for example, when you are analyzing the entire oil production that comes from an oil field, there are many reasons that that cause that the workers need to shoot in the wells, that they need to close the wells. For example, if you're talking offshore oil rig, if there is a hurricane uh, or is a natural catastrophe, they need to close the production. And in one single oil rig, they connect production for many wells. So in the reported production, some hurricanes or some disaster uh, take 1 month. So this affects a lot the production. And also when they are restarting the production, this affects the reservoir, because it's like when you are doing oil well testing, the pressure inside the reservoir when you close the well affects, because it's a wave of propagation of drop of pressure or increase of pressure. In this case, the pressure increases inside the well bore. There, when the compression reaches its maximum, the there is a increase of pressure because the oil is not flowing from the reservoir to the wellbore. So when you are also opening again the wellbores, the production has some differences. So you need to understand the data. When you're analyzing production data in oil industry, you also need to check the logs of the activity. For example, what happens if you have a peak of production in your data? You have to check the logs, where the production comes from. Maybe they drill 10 wells in once, and they start the production in just with one movement. They were opening production, so you are going to have a lot of production increment. So how can you model this in a statistical model? Or for example, well, somebody decides to do a workover uh, to change the sand that you're producing, or when you are working with artificial lift system, how you are going to analyze these kinds of events. So you need to set labels of the compare the production, the statistical production with the logs of the activity in the reservoir. So in the oil industry, normally the engineers they don't go for the molecule, but they go for the money and the big numbers, the production and the spending also. The spending is very important when they are drilling wells. They must do it in a short time. Otherwise, they will spend a lot of money. So in terms of real parameters, uh, we don't go to the molecule, so the model won't be perfect. Also, we're analyzing in this case the entire production from the reservoir. But in other cases, you can analyze the production of one single well that could be more precise. Uh, Also, there are models for example, in uh, uh, there are some type curves for oil well declining curves. The ARPS curves that comes in uh, exponential declining, logarithmic declining. Uh, but well, you can use this specific declining exponential and fit the model in for your well for one single well. You can do that, and also with the linear regressions, you have the parameters, minimum square error, and everything. How you validate your results? Well, with the reality, you compare what is the production is the same for when you are doing a reservoir simulation. You have to compare your computations with the real production, with the actual production. So if the reality is equal to your values that you are computing on your calculator, on your laptop, on your machine, then you are doing a good fit. But otherwise, you are not.
I think Anthony will be satisfied with your answer, I guess. Yeah.
Okay.
Any other questions? There are some comments that it was an amazing presentation. It
Thank you
was
very
a
much.
very nice webinar. Any questions, participants, or shall we wind up? Yes, sure, Anthony, you can. I think the webinar is over right now, and we can wind up and can close the session.
Okay. Thank you very much. Have a nice day. Goodbye.
And a nice evening. Thank you, Mr. Oscar, and thank you all the participants for joining. Your certificates will be shared within 1 or 2 days. Okay. Thank you.
Thank you so much. We really appreciate it. So.